Okay, I hope you can hear me. That's fine? Okay. Yeah, you know, Daniel, thank you for the introduction. My name is Carsten Bock, and you may know me from such popular modules such as the IMS online charging server or lots of other IMS-related modules. So let's start a little bit off. During the last year, we did a lot of voice over LTE projects on mobile networks, on fixed networks, and we also did a lot of web RTC as well. And well, doing all the same stuff over and over again is somehow getting a little bit boring. So we decided, as a first step, let's make Kamailio great again. Yeah, let's do it. And we're going to build such a fantastic diameter server. Diameter? What the fuck? Why do you want diameter? What is diameter as such? First of all, let's see what's diameter. Okay, I usually come up with a question. If you look at diameter, what is a diameter compared to radius? Does anybody know it? Twice the radius, exactly that's the answer. Diameter is actually an evolution of radius. So they basically took the stuff they had in radius and they improved it quite a lot. If you look at IMS, both fixed line, mobile networks, diameter is everywhere. You see the home subscriber server, the central provisioning database, it's queried using diameter. If you do policy, like quality of service settings, then you use diameter to send those quality of service settings to the network cell. If you do charging, of course, we do charging via diameter, the RO and the RF interfaces for online, offline charging. And even if you run applications, you should do it using diameter if you want to query some information about, for example, registration status. So quite often I get the question, and if people work with me, they really tell me, well, if you could, you would probably do everything in Kamailio scripting. And I totally understand why they think that, but to be honest, this is not entirely true. People say, well, okay, Kamailio is a zip router. It should do zip, right? Does everybody agree on this? But if you look at Kamailio nowadays, it can do way more than just the zip. It can do so much more than zip. One reason why we built our IMS server on top of Kamailio is it has actually a really very good diameter stack. The diameter stack is robust, it's really working extremely fast, it's working really, really well. And Kamailio as such has various interfaces to other systems like RabbitMQ, like databases, like NoSQL databases, like Redis or Mongo or anything else. We can actually even do REST requests from Kamailio scripting or even HTTP. And I think even with the latest contributions by Daniel, it's getting more and more interesting to do things on Kamailio. Let's take a little bit deeper look into diameter. Yeah, okay, the screenshot is not really good, but if you look at the diameter protocol as such, you will actually see that our diameter message is basically just a set of attribute value pairs. And each attribute you're sending on diameter has a specific code and some flags and some content and some payload. So it's fairly okay, it's readable. So we built an IMS diameter server on top of Kamailio. And one really, really cool thing about this is that you actually can really do anything you want with your diameter request within the Kamailio script. And you can actually even do, I haven't tried it yet, but that's surely possible. You can actually do diameter processing in JavaScript or Lua or whatever you want, whatever kind of configuration script you're running. It's really, really up to you. This is really cool. This is really, really flexible. What our module does is we take the diameter request, we take some parts where we're looking at very specifically, and then we translate that into a JSON object. And with the JSON, we can then do whatever we want. And JSON, we basically took JSON because it's interoperable. Like there's the Johnson modules on Kamailio, so you can do a lot of stuff with JSON in Kamailio script itself, or basically any language you're dealing with has support for JSON. The script really allows you to process the request. You get the request, you can take all the values that are in this request and generate an according answer. And it also allows you not only take a request, produce an answer, but also the other way around. Like you can actually you can create a request from script and send it to a diameter peer, which is quite convenient. If you do Kamailio, if you do diameter in the Kamailio script, we are actually sending it to a dedicated event route. So if you look at our HSS configuration file, you will actually see in the main route, there's only drop. We don't do any zip here, we just do diameter. And all of our incoming requests end up in the diameter request event route. In this diameter event route, we've got some variables that we are exporting. And that's, okay, this is a little bit more detailed into the protocol. That's basically that we need the application ID, and the application could be something like the RX interface for quality of service, or it could be the CXDX interface for communicating between the IMS core as such and the home subscriber server. It could be SH, could be any kind of diameter protocol you want. And so you get the application you want to run, like online charging, RO. You get the command code. The command code is something like, I have a specific interface between, let's say, my serving CSCF and my charging unit, and then I have a specific command code to do the initial request, to do an interim request, to do the final request. The request as such, you get another variable, which is a diameter request variable. I hope that's self-explanatory. The response you want to return to the requester goes in another variable, which is the diameter response. I think from my perspective, this is really straightforward. If you want to send a request, we just added another function, which is diameter request with application ID, command, and the payload. Our Kamailio IMS server module is in the trunk version of Kamailio for, I would say, almost a month or something like that. We've actually been using that in production for a little bit longer. We've been really testing that a lot. So, okay, now you can do Kamailio, you can do a diameter with Kamailio. Isn't that great? Yay! That's the answer I want to hear. Because you can now do really a lot of exciting things with it. Okay, you can build a home subscriber server. And having a home subscriber in the mobile network is really crucial. And it's really something that we need. Building a home subscriber server on top of this was the main reason why we implemented this module. You can actually even build a policy and charging rules function, which is, okay, again, this is a little bit related to mobile networks, but it's a function to do the quality of service, to do a bandwidth assignment, to do all kinds of stuff you'd want to do in terms of policy on the network. You can do a diameter routing agent. Just take a diameter request, change some headers maybe, and simply send it to another peer. If that's what you want, you can do it with our new module. And of course, you could build your charging system on top of this. And this is something which is, I think, also a quite interesting and a quite exciting possibility for this module. And later on, I will actually show you why. You can build, quite frequently we have applications, application servers for our IMS deployments, which are also on Kamailio, because I love Kamailio. And I not only love IMS, but I also love Kamailio. So in theory, you could actually even do SH for your application server with our module, which is, I think, great. So you can actually, anything that does diameter on your network, you can build with Kamailio now, which is, I think, for me, it's totally awesome. So why did we do that? In our deployments, there was always one really, really big pain point. And that was actually the home subscriber server. If we integrate IMS into mobile networks, then quite frequently there's an existing home subscriber server, so that point was solved. But sometimes, especially if you do fixed line, okay, we need a home subscriber server. Initially, we used the Open HSS from Fraunhofer. Is Dragos here from the Fraunhofer Institute?
No, I don't think so. You can be rude.
Okay. I really have to mention, well, this works, but it sucks somehow. It's really slow, and it's, yeah, not really nice. As a first attempt, we tried to replace the Open HSS from Fraunhofer. And initially, we did this with JBoss, MobiSense, and JDiameter. This was faster, okay, but it was a little bit, for us, it was a little bit install the software, forget it, and please don't touch it. It runs, and don't touch it. And one reason we never made it really open source was there were so many points where we said, okay, we should fix that. This is not nice. We should improve this, and yeah, you really don't want to give that away. Not everybody should see what crap you're doing below the hood. So, based on our development in Kamailio, we actually built the Kamailio HSS server, which is quite interesting. Okay, of course, I have to say it because we developed that, so it's quite interesting. And the architecture here is really, really nice because on the one side, we have the diameter servers, the diameter peers, which speak to our other IMS components. And as I mentioned before, they basically do diameter translated to JSON. And even though bad people say I would do anything in Kamailio routing logic, in this case we didn't. For another project, we implemented a RabbitMQ module for Kamailio, and so we also used this for the HSS diameter server. And this really served us well. What we basically do is take the diameter request, translate it to JSON. This is done on Kamailio. And then we put the request into the RabbitMQ message bus. Then there are several worker processes. And each of the worker processes simply look into the queue. Is there something new? Is there a new request coming? And once they have a request, they get a request, they simply produce an answer, which is again JSON, and put it back onto the queue so the diameter peer can actually send out the reply. In Kamailio and in most likely a lot of other projects, you would use something like C or Java or something like that for the worker processes. And we implemented actually the worker processes in PHP. And the reason for this is actually because we're quite comfortable with PHP. We're trying to reduce the number of languages we use in our project. So it should be C for Kamailio and everything that's media and signaling related. And we use PHP for management interfaces, REST APIs, everything else too. So actually this, having a worker process implemented in PHP was, yeah, let's try it. And this served us quite well because having PHP as a worker process made it really easy to adapt the HSS. Like for example, we had some cases where we had to change the reply, we had to change certain values in the reply. So it was really just quickly, easily update some PHP code, restart the worker process, and it's done. It's done. It also, due to this architecture with the RabbitMQ in the middle, it really scales up quite well. It really scales up because the RabbitMQ you can actually distribute about on several servers, and you can have as many workers as you like. And you can also have as many diameter gateways as you like. It's really, if you need more performance, just add more servers, add more hardware. And what really, really amazed me was that this setup was extremely, or I shouldn't say was, it's still extremely, extremely fast. You should, my personal imagination, my personal idea was, okay, like we had our JBoss Java implementation, and I was expecting something similar. I was really expecting something similar from the Java JBoss MobiSense HSS we had. But this setup, even with PHP scripting language as a worker process, in total was like 10 times as fast, which was really like, wow, this is really great. And we didn't change the database behind, we didn't change anything behind, we just simply replaced the worker processes and the diameter gateways. And it was really, wow, this is great. Yeah. So this is basically our home subscriber server that we built. And this, for us, this is only the first step. We plan to really add more features to this. And not only in terms of the home subscriber server, which we need for all kinds of setups, but also to the diameter stack and other things. First of all, on the diameter module on Kamailio, we want to add native SCTP and native TLS. We want to do HOMA integration because at the moment you just see the signaling, you see a register coming in and a reply going out, and in HOMA you really don't see what went wrong on the diameter side. Like did the home subscriber server simply say, okay, this user doesn't exist, or what really happened there? So we really want to do some HOMA integration so you really can see, I made a registration and I sent out this following diameter request, got the following diameter reply, and see how it goes. This is something, a part that's really missing. About SCTP, this is something where I've heard that people had hacks to make SCTP work with Kamailio, and I think we should do some more native SCTP. The idea basically we have in mind at the moment is basically a little bit like the HOMA project as such, that we take the usual TLS SCTP listeners and create some sort of no-zip, but just diameter module instead. On the application side, if you look at our home subscriber server, you will see that we only have the CX-DX interfaces at the moment because we're driven by requirement and not what should be to be feature complete, because at the moment, for example, we didn't implement SH on the home subscriber server because we don't have any applications to query SH. So it didn't really make sense. Another thing that we will do later this year is actually we want to implement a PCRF simulator for RX testing. Because at the moment, if we deploy IMS for mobile networks, all this stuff related to RX, to the quality of service bit, is a little bit, it should work. We've tested it some time ago with a real mobile network, but since we don't have a real RX interface in our lab, we need to do something there. Some of you may have noticed that we have a small femtocell in our lab. And another thing that we want to do on our HSS, we want to do a little bit deeper integration into that femtocell. Because if we integrate into that femtocell, we can, for example, if we build a PCRF simulator, we can actually do the dedicated bearer setup, which is mandatory for voice over LTE. Or we can actually even do all kinds of synchronization in terms of SIM cards, stuff like that. Probably on the midterm, I think we're gonna also integrate the IMS OCS module, which I think I presented last year. I think we're gonna integrate that into our IMS diameter server as well, because it simply works that good. And the greatest thing of it, since the software we wrote for the home subscriber server is really, I wouldn't say the cleanest code, but it's okay. We're making it all open source. If you listen to my workshop on Monday, you already saw that we have Debian packages for both for the REST API, both for the management interface, and also for the home subscriber server in our repository. And you will actually, since it's purely scripted in PHP, actually if you download the package, you already got the source code. But we will also put it on GitHub, hopefully tomorrow. Yeah, I think that's it from my side.
Oh, thank you. That sounds really interesting. On open source HSS, I can see James smiling already, and I can feel support for PHP and Kemi coming from the other side, joking now. But yeah, questions. Again, thank you for the last contribution, a lot of IMS-related modules. Who has questions? James?
Yeah, it's not the question that you're expecting. I mean, have you had anything to do with the guys from Open Air Interface, the Osmocom guys, at all?
No.
Because they're here, actually here in Berlin, and I said, get yourself down and come and talk to the Kamailio people, and they refused to come. It's really silly.
The Osmocom guys, they're basically focusing on 3G, and I have the feeling they don't touch 4G, they don't touch LTE, and for us, we don't touch 3G. So
They're
yeah.
not touching LTE.
Okay.
Yeah, and there's a lot of overlap.
Yeah. Huh? Okay. Maybe I should get in touch with them. Yeah.
Yeah.
Other questions?
Okay, one more question, so we move quickly out. My question about that Rabbit MQ, so, and the workers, so practically you created another PHP worker on the fly, like, because it's kind of independent application, right?
As a worker process, basically the worker process are up and running, and but you can actually do. You can simply spawn another worker process on the fly if you need more performance. And they will simply just hook into the RabbitMQ and take whatever it's there. So it's really easy to scale up.
Okay, so actually, last question there.
Hi. In the Kamailio routing blocks, it had lots of information, but it didn't seem to specify the realm information. Can that be extracted or used for example, routing purposes if you wanted to do a DRA or a DEA type?
Definitely. You can access anything that's within the diameter message, so...
That's within the diameter?
Exactly.
Block. Okay.
So it's up to you.
Okay, thank you, Carsten. Thank you again for all your support to the event.